In this video, we're going to introduce you to the very important concept of conditional probability. So if you look right here, it says the probability of A given B. That's what the vertical line means. In other words, what's the probability that event A will occur once you're told that B has occurred? And the answer is you take the probability of both A and B occurring divided by the probability of B. I think we'll see this when we go through our examples that it makes sense. Now, we can relate this to independence, which we just talked about in the previous videos. Events A and B are independent if the probability if and only if the probability of A given B is the probability of A. In other words, if I tell you B occurs, it doesn't change your view of the chance of A occurring. And also the probability of B given A is the probability of B. In other words, if I tell you A occurs, it doesn't change your view of the chance of B occurring. And you can rearrange this equation up here one of two ways. You can say the probability of A and B, if you multiply by probability of B, is the probability of B times the probability of A given B. In other words, to find the probability of two events occurring, take the probability of one of them times the probability of the other given the first has occurred. And you could also flip it this way. The probability that A and B occurred is the probability the first one occurs times the probability of the second given the first. And usually one of these is easier to do than the other. That'll be very important when we talk about Bayes' theorem. In other words, you want the probability that two events occur, you can take the probability of one of them times the probability of the second given the first, or the probability of the second times the probability of the first given the second. Either way is fine, just work with the information you have. So let's look at two examples here. In this case, A and B are not independent, and we're supposed to want the probability of A given B. It's, again, the probability of A and B divided by the probability of B. So there are 20 points in the sample space, 5 times 4. How many of these are A's? 1, 2, 3, 4, 1, 2, 3, 4. So the probability of A will be 8 over 20. Now let's get the probability of B. How many B's do we see here? I think we see 4. Okay, so now what's the probability of A given B? In other words, if I told you we're in B, okay, which is the yellow here, does that change your chance of A occurring? Well, we need the probability of A and B, that's the numerator here. We've got the probability of B. The probability of A and B, we just have to look here. Okay, there's 1 point that's A and B out of 20. So the probability of A given B is the probability they both occur, which is one of those points. Again, Excel loves to think it's a date, so I'll do it like this. Then I would divide by the probability of B, the given event, and that's 4 over 20. So 120 divided by 4 over 20 is going to be 1/4. Okay, so now when I tell you that B occurs, the probability of A given B is now 1/4. Okay, but the probability of A originally was 0.4, 8 over 20. So it's changed. In other words, once I tell you that B has occurred, it makes A less likely. If you look at the picture, you can see that. When I know it's yellow, it's much more less likely that it's orange. So basically, those are not independent events, and we've illustrated the concept of conditional probability. Now here, A and B are independent, and we'll be able to check that by using conditional probability. So let's do the same thing we did before. We want the probability of A and B, or we want the probability of A given B. Okay, so let's work from the probability of A. So how many A's do I see there? 1, 2, 3, I see 8 out of 20. Okay, again, there's 20 points in the sample space there, 4 times 5. Now let's find the probability of B. It looks like I've got 5 B's. And how many times do I see A and B? Well, that is different here. There are 2 points that are A's and B's, right? You see them right here. Okay, so probably if A and B is 2 over 20. Okay, so now the probability of A given B is the probability of both. Okay, so A and B is going to be 2 over 20. Again, Excel thinks it's a date, February 20th. divided by the probability of B there, which is going to be 5/20. And that's 2/5, okay, which is 0.4. So the probability of A given B is 0.4, but the original probability of A was 0.4, so the A and B are independent. In other words, when I told you that B occurred, it didn't change the chance of A occurring. So conditional probability can be used to show independence, but it's actually a much more powerful concept. So in the next video, we're going to do two sort of more realistic examples of conditional probability.